Imagine a world where travel is not just about the destination, but the journey itself is an adventure. Today, we're exploring 15 future train concepts that promise to revolutionize the way we think about rail travel. Let's start with number 15, Hyperloop Trains. The Hyperloop, which is a concept that was first introduced by Elon Musk in 2013, is a new transportation technology that promises, if implemented, to change the way we travel over medium distances. It's an ultra-high-speed ground transport system that aims to transport passengers and cargo pods through a low-pressure tube, potentially reaching speeds of up to 750 miles an hour by combining reduced air resistance and magnetic levitation technology, making it faster than conventional rail networks and even some commercial flights. The idea behind the Hyperloop is to create a near vacuum in the purpose-built tubes, which significantly reduces air resistance, which is one of the main limiting factors in the speed of traditional rail systems. By doing so, it allows the pods to travel at much greater speeds with much less energy than would normally be required. The pods are designed to float above the track using levitation systems, which further reduce the friction and, crucially, enable a smooth ride. One of the most important aspects of the Hyperloop concept is its potential environmental impact, as it's possible to power it solely with renewable energy, such as solar panels installed along the length of the tube. This eco-friendly approach is significant in the context of growing concerns about climate change. But while it does sound great, there are a number of hurdles that still need to be overcome. The construction of the tubes is hugely expensive, much more so than high-speed rail lines, and there are further safety concerns about how you'd be able to handle emergencies within the tubes where access may be limited. Still, several companies and research groups are already exploring this concept, conducting feasibility studies and developing test tracks, and if all goes well, a functioning Hyperloop network could be operational within a decade or two. Number 14, Biometric and Microchip ticketing systems. So with transport networks continually being upgraded so they have a greater capacity, there's part of the passenger experience that in most places still takes up far more time than needed: the process of buying a ticket and how they're checked when you board. Various companies are investigating how to use technology to streamline this process, and a much simpler system could be closer than you think. Biometric and microchip ticketing systems are increasingly being integrated into train travel, and not only do they speed things up, but they're also more secure and convenient. Now, biometric ticketing involves using a unique biological characteristic of a passenger, such as fingerprints, facial recognition, or iris scans for identification and access. In the context of trains, this could mean passengers simply walk through a gate that automatically identifies them through facial recognition or a fingerprint scan, and completely eliminating the need for a physical or even electronic ticket. This not only speeds up the boarding process, but also significantly reduces the possibility of ticket fraud or loss. Microchip ticketing, on the other hand, involves embedding a microchip into a wearable device or even under your skin. These chips can store data like a passenger's ticket information, identity, and payment details. With near-field communication technology, a passenger can gain access to a train service by simply placing their hand or a wearable device near a scanner. This method streamlines the ticketing process as it removes the need for checking in or manually scanning a ticket. There are already a number of transport networks around the world that make use of some of these ideas, such as storing tickets on a mobile device that can be scanned at a barrier. But a future where the gates actively recognize you to let you pass and perhaps even control the onboard lighting to show you directly to your seat will substantially increase the efficiency of any railways they're linked to. Number 13. AI-controlled autonomous trains. So there's a huge focus right now on the potential for autonomous vehicles, but with the way that trains are confined to the tracks they run on, it is possible similar technologies will be rolled out across the railway networks far sooner. Using advanced artificial intelligence, these trains are designed to operate without human intervention, relying instead on sophisticated algorithms, sensors, and communication technologies to navigate routes. The potential of AI-controlled trains lies in their ability to perceive and understand their environment. Now, this is achieved through an array of sensors such as cameras, radar, and LiDAR, which continuously monitor the train's surroundings. These gather vast amounts of data from track conditions and weather to potential obstacles and signaling information, and algorithms can then process this in real time and enable the train to make instant decisions, such as adjusting speed, stopping, or changing routes, in order to ensure optimal safety. One of the biggest advantages of autonomous trains is the potential improvement in safety by eliminating the chance of human errors. Furthermore, AI systems can operate with consistent attention and precision and are unaffected by fatigue or distraction, which further increases safety and efficiency. They'll also lead to substantial financial savings for railway operators, as the reduced need for human drivers and the increased efficiency in operations can lower labor and operational costs. So too can AI-driven predictive maintenance that will foresee and address mechanical issues before they lead to breakdowns, reducing maintenance costs and downtime. Now, of course, this is as controversial as it is potentially beneficial, as it would risk hundreds of thousands of jobs around the world. In some countries where operators are rolling out autonomous features, they're attempting to relocate staff to other areas. But there'll be no avoiding the fact that many people will end up looking for jobs elsewhere. As with many other industries facing similar questions around the use of AI, it's likely this issue, as opposed to the technology being readily available, that will delay or even prevent it from happening. Number 12. Augmented reality windows. So, augmented reality windows on trains are an innovative technology that's designed to transform the passenger experience during travel. Currently, you're able to look out and see the world passing by at high speed, but what if this space was used in a different way? AR windows can, for example, display dynamic information and entertainment directly onto the window panes, augmenting the real-world scenery with digital overlays. And this integration of virtual content into the physical journey can provide both practical and entertaining benefits to make the journey more productive or enjoyable. From a functional standpoint, AR windows can serve as an interactive travel guide, providing passengers with real-time information about landmarks, towns, and geographical features they're passing by. They could offer historical context, maps, and tourist information, or for business travelers, these windows could double as work screens, allowing for the display of emails, news updates, or meeting reminders, all while keeping an eye on the passing landscape. For leisure, AR windows can elevate the travel experience by turning the journey into an interactive adventure. Children could be able to play games with the landscape, whizzing by, turning a routine trip and engaging in a fun experience, or travelers could enjoy a virtual tour of a passing city's highlights while comfortably seated in their train car. In what's probably a less exciting feature for passengers but potentially beneficial for operators, AR windows could also be used for advertising and commercial partnerships, and see trains displaying geo-targeted ads relevant to the location and time of day, offering a potential revenue stream for rail operators. Already, this technology has been integrated into some trains in Japan and elsewhere in the world, but as it becomes more affordable, it's likely to be retrofitted into existing stock, as well as included as standard in new trains, so you'll probably start seeing it being used very soon. Number 11. Quantum levitation trains. Quantum levitation, it's also known as quantum locking, is an emerging technology that could revolutionize the concept of train transportation through the principles of superconductivity and magnetic levitation. Quantum levitation trains would operate using a phenomenon where a superconductive material is cooled below its critical temperature and exposed to a magnetic field, which causes it to levitate above a magnetic track. At the heart of this technology is the unique interaction between a superconductor and a magnetic field. Now, superconductors, when cooled to extremely low temperatures, have zero electrical resistance and can expel magnetic fields, which is a property known as the Meissner effect. However, in a modified superconductor, the magnet field can penetrate in tiny quantized tubes of flux, and when this superconductor is placed over a magnet, these flux lines sort of get pinned in defects of the material, which lock it in place. This allows the superconductor to hover above the magnet and maintain its position even when the setup is tilted or the track below it curves. For trains, this technology offers a wide range of benefits. Quantum levitation trains would virtually eliminate friction between the train and the track, allowing for highly efficient high-speed transportation. The absence of friction not only means faster travel but also less wear and tear on the tracks and vehicles, leading to lower maintenance cost. The infrastructure cost, though, is currently prohibitively expensive, with some estimates being that it would be at least 10 times that of the current high-speed rail lines. Perhaps in some short-distance routes, though, it'll one day become a reality, but most countries are looking for far more affordable choices for infrastructure development. Number 10. Solar power. So, solar-powered trains are an exciting step towards the goal of a fully sustainable mass transit, and it can harness the sun's energy to generate all the power that's needed to operate a train and all the systems on board. This can be done either directly or indirectly. In the direct method, the solar panels are installed on the roof of trains and convert solar energy in real time to power the train's operations. On the other hand, the indirect method involves generating solar power at off-site locations or along the tracks, which is then fed into the grid or directly into the train's power system. Both methods significantly decrease reliance on fossil fuels, and it promotes the use of clean energy. There are huge benefits that could come from rolling this out. Environmentally, they offer a massive reduction in greenhouse gas emissions, but the operational costs of solar-powered trains can be lower than those of traditional trains, as sunlight is a free and abundant resource. It's also not feasible in all countries, as the availability of sunlight isn't as reliable in some places as it is in others, but in places where it's sunny a lot, the concept has real potential. Some countries have already begun operating trains partially or entirely on solar energy, showing that the technology is already advanced enough for it. It's just the investment that's needed. For example, the Byron Bay Railroad Company operates a fully solar-powered train in Australia, and India has begun to trial trains with solar panels on their coaches. Number 9. Active suspension. Active suspension in trains is a sophisticated technology designed to significantly improve ride quality, stability, and speed on rail networks. Now, this system dynamically adjusts the suspension response in real time to track conditions and train movements using a variety of sensors, actuators, and control systems. Traditional suspension systems on trains have been passive, meaning they react to bumps and track changes without active intervention. Active suspension, on the other hand, anticipates and reacts to these conditions by controlling the force in the suspension. It uses onboard sensors to detect movements and vibrations and then automatically adjusts the dampers and springs accordingly. The main benefit of this is improved passenger comfort. By actively dampening vibrations and jolts from track irregularities, the system ensures a much smoother and more pleasant journey. For high-speed trains, which are becoming more and more common, active suspension is even more critical in maintaining a comfortable ride while traveling at speeds where even small bumps can be disruptive. It's not all about comfort, though, as active suspension can also improve the overall safety. By keeping the train carriages more level and stable, the risk of derailment is reduced, especially at higher speeds or on less than perfect tracks. It'll also contribute to reducing ongoing costs for both the trains and the tracks, as by minimizing the impact of the train on the track, wear and tear on rails and wheels are decreased, leading to lower maintenance requirements and longer track life. This also means trains can maintain a higher speed for a longer period without significant track damage, and as a result, it will improve the overall efficiency of the rail network. Number 8. Drone-integrated freight trains. So, drone-integrated freight trains, they have the potential to combine two transport methods to majorly improve transport efficiency by solving the last-mile delivery problem, where the final leg of the shipment's journey to the customer's door is often the most complex and extensive part of the shipping process. In a drone-integrated freight system, trains essentially serve as mobile logistic hubs, carrying goods across long distances, while drones are deployed to handle the final delivery from the train to the end destination. This system makes the best use of energy efficiency and bulk carrying capacity of trains, with the agility and versatility of drones. Trains can transport heavy loads over large distances using established rail networks, which is much more energy efficient and less costly than road transport. And then, once near the destination, drones can be dispatched directly from the trains to deliver packages in hard-to-reach areas, or to bypass traffic and other obstacles that delivery trucks have to contend with. If it's implemented properly, it could bring a wide range of benefits to haulers and customers. Drones can, for example, rapidly deliver time-sensitive cargo, such as medical supplies or perishable goods, directly from the train to the customer. This is a particular benefit in rural or remote areas where road access may be limited, and the train wouldn't even necessarily have to stop, instead retrieving the drone later down the line after it's completed a delivery. It would also mean that drones can be used to manage fluctuating delivery volumes, handling peak demands without the need for significant changes in ground transport capacity. It would allow for a more responsive supply chain that could quickly adapt to changing market conditions, and it could reduce the number of vehicles on the road, which would improve things for other road users. Number 7. Vertical trains. You normally think of trains traveling horizontally from place to place, but in the cities of the future, they may well need to move in a different direction. Concept of vertical trains proposes the idea of trains operating in a vertical or near vertical orientation, and it could see trains going up the sides of skyscrapers or mountainsides. It is a clever solution to the problem of urban congestion and the scarcity of horizontal space in densely populated cities. By moving vertically, trains could directly link the ground level with upper floors of high-rise buildings. This could significantly reduce the need for elevators or additional ground transportation, and streamline the flow of people within urban environments. Of course, this wouldn't be possible using traditional rails, but it could be done with magnetic levitation tech or advanced cable-driven systems, which would allow for the smooth and efficient climb and descent. The trains could be designed with adjustable cabins that rotate to keep passengers upright regardless of the train's angle of travel, and be compatible with the current transportation infrastructure. Safety would be ensured through redundant systems and clever engineering to ensure that even in the case of a power failure, the train could safely be brought to a stop or returned to its base. The integration with buildings could further facilitate the development of multi-use vertical spaces, blurring the lines between transportation hubs and commercial or residential zones. Of course, we are far from this concept being a reality, and it still seems more at home in a sci-fi movie. But as we continue to build upwards, they could well become the norm. Number 6. Energy harvesting trains. With all the modes of transport out there, trains essentially waste a lot of energy. Rather than burning all of the fuel or using electricity to produce the motion, they also create a lot of sound and heat. This is where the concept of energy harvesting trains comes in. In a similar way to what happens in the braking systems of some cars, the idea is that there are ways of capturing this wasted energy and reusing it to power various aspects of the train's operations, or even feeding it back into the grid. The primary method of energy harvesting in trains is through regenerative braking, so when a train slows down, the kinetic energy, which would typically be lost as heat through conventional brakes, is instead converted into electrical energy. This energy can be stored in onboard batteries, effectively reducing the overall energy consumption of the train. In urban rail systems, this technology is particularly beneficial, as frequent stops allow significant energy recovery. Another smart approach is the use of piezoelectric materials in the tracks. Now, these materials generate electricity when compressed, so as the train passes over, the weight and motion of the train produce electrical power. This power can be used for station operations, signaling, or even nearby communities. Wind turbines, too, are another potential avenue for energy harvesting, with small turbines being mounted on trains or along tracks and capturing the wind that's generated by the train's movement. As the technologies behind these ideas improve, they'll begin to be implemented more commonly, and in many ways, what works in other transport systems will work for trains too. Ideas developed for cars will be transferable and vice versa, meaning development in one area to increase the use of green energies will benefit plenty of others as well. Number 5. Modular Trains. While trains are inherently modular already, with the ability to change the coach configuration, there are limitations to when and where this can be done. Operators are now looking for new technologies to make this far easier, with true modular networks offering the potential to be far more efficient than is currently possible. The concept allows for the individual carriages of a train to be easily added, detached, or reconfigured according to real-time demand, route requirements, or specific service needs. During peak hours, additional modules can be coupled to accommodate more passengers, while off-peak times could see the train downsized for efficiency. Another useful feature is the ability to mix different types of carriages within the same train. For example, a modular train could consist of passenger carriages, a dining module, a cargo section, and even a luxury lounge or sleeper compartment. The coupling and decoupling process in a modular train system is designed to be swift and automated, minimizing any delays, and could take place at designated stations or even while in motion through the use of advanced docking systems. As a result, part of a train could detach and head to a different destination without requiring the entire train to make an unnecessary detour. From a maintenance perspective, modular trains offer significant advantages as well, as individual models can be removed for repair or upgrading without taking the entire train out of service. Infrastructure upgrades would of course be necessary for this to happen, as stations would need to be equipped to handle the dynamic coupling and decoupling process, and rail networks would have to be managed with precision to accommodate the flexible nature of these trains. It could, though, be one of the cheaper options to upgrade a rail network, particularly in the short to medium term, and allow operators to make more of what they already have in place. Number 4. Hydrogen power. So most trains are either diesel or powered by electricity, but currently neither is particularly green in terms of energy use. It could be decades until most of our electricity comes from renewable sources, but there's a potential alternative that would significantly reduce emissions related to trains: hydrogen. The adoption of hydrogen power in trains offers a number of benefits. Firstly, it allows for the use of renewable energy sources, as hydrogen can be produced using the surplus renewable electricity through a process known as electrolysis. This means that the entire energy chain can be sustainable, provided the hydrogen is produced from green sources. Secondly, hydrogen-powered trains offer a practical solution for non-electrified rail lines, where the cost of installing overhead electric lines can be prohibitively expensive. Trains that run on diesel can also be converted to run on hydrogen, further reducing the cost of implementing it. And all that would need to be added to the networks are hydrogen refueling stations. When running on hydrogen fuel cells, trains would produce electricity through a chemical reaction between hydrogen and oxygen, with water vapor as the only byproduct. They're much quieter than diesel trains, which would be particularly welcome in rural areas, and the fuel would, in the long run, also be cheaper than diesel, thanks to the decreasing cost of hydrogen production and the long-term savings from reduced maintenance. There are already several networks around the world that have been trying hydrogen-powered trains, and while it's not yet at a stage where it's an economical alternative, it could be the best way to reduce emissions from the train industry quickly while waiting for improvements in electricity production. Number 3. Suspended sky trains. Suspended sky trains, also known as hanging trains or monorail systems, are a mode of urban transport that in the coming decades are likely to become more and more common. These systems typically involve a single rail track or beam with a train carriage suspended beneath it, gliding above the streets below. This form of transit offers a unique solution to urban congestion and space constraints by using the airspace to transport passengers between destinations. While the idea may not be new, there are already some SkyTrain networks in busy cities. The technology has significantly improved, as the demand for smart mass transit systems will reduce our reliance on cars. The design of suspended sky trains involve carriages that hang from a fixed track, often powered by electricity, and the elevated nature of the tracks allows these trains to bypass traffic and ground-level obstacles. The trains are stabilized by gyroscopic forces which naturally keep the carriages upright and ensure a smooth ride for passengers. Not only do they need far less space on the ground than can be used for other purposes, but they're also much quieter than trams, metros, or other vehicles, so can be used to help reduce noise pollution. When trying to reduce emissions, suspended sky trains can be powered by clean energy sources, and their efficiency is moving large numbers of people can also help to reduce reliance on personal vehicles. Furthermore, the construction of suspended sky trains can be far easier and less disruptive than building underground metro systems. As with much of the work occurring above street level, it can often proceed with minimal interference to existing traffic and without the need for extensive and costly tunneling operations. Number 2. Virtual coupling. The most popular train routes around the world are often running at full capacity, and while one option is to build more tracks, another is to more efficiently use what's there already. Currently, lines are essentially separated into different blocks by signals. For safety reasons, only once a train has passed a signal can another train enter the block that it's just traveled through, and this means that there's a hard limit based on the infrastructure, on the number of trains that can be in service at any one time. Virtual coupling, though, could change all this, and this technology allows multiple trains to operate as close-knit convoy without physical connections. The idea behind this concept is based on wireless communication technologies such as train-to-train communication protocols, which enables trains to share information in real time about their position, speed, and acceleration. And each train in the convoy acts autonomously, yet is coordinated with the others, much like a flock of birds moving together. The main benefit of a system like this is the increase in line capacity. By safely reducing the distance between trains, more trains can travel on the same track within a given time frame, thereby increasing frequency and overall capacity. This efficiency boost is particularly crucial in dense urban networks where tracks are often a bottleneck. Furthermore, virtual coupling can improve the flexibility and scalability of train services. Trains can join and leave the convoy dynamically, allowing for a modular approach to rail transport. Theoretically, virtual coupling can lead to smoother rides and reduced energy consumption, as trains can accelerate and decelerate simultaneously, so there's less stop-and-go movement compared to traditional rail operations. This overall synchronization would then lead to energy savings through more efficient driving strategies. It is, though, a huge technological undertaking to make all this possible, and it's not entirely clear if the systems exist yet to make it work. With all the progress in autonomous vehicles, though, similar solutions will need to be developed, so it could be possible for trains within the next decade. Number 1. A plane/train hybrid. So we're used to different modes of transport operating independently of one another, but what if they could, in a way, be combined? The concept of a plane and train hybrid looks to blur the boundaries between rail and air travel and could lead to a new class of transportation that combines the speed of flight with the convenience and accessibility of the railways. To do this would require the creation of a vehicle that can operate both on a railway track and in the air. This wouldn't be easy, and it would need advanced materials and engineering to address the differing requirements of aerodynamics for flight and the traction needed for rail travel. The hybrid would likely be equipped with retractable wings or tilt-rotor technology, allowing it to transition from a train-like mode on the ground to an aircraft when in flight, or potentially have extra parts that it connects with at an airport to fully transform. One of the biggest advantages of a concept like this is the potential to significantly reduce travel times on routes where direct flights are not available and train journeys are too long to be practical. By combining the two, the hybrid could offer a direct service without the need for connecting flights or transfers. This could result in more direct routes between cities and an overall improvement for connectivity and efficiency. The use of such a vehicle, though, would require significant infrastructure development. Airports would need to be equipped with rail tracks, while railway stations may require runways or vertical takeoff and landing capability. This dual infrastructure would allow the hybrid to operate effectively and transition smoothly between air and ground. If it worked, however, it could alleviate the pressure on congested airports and reduce the need for short-haul flights, which are less fuel-efficient and contribute significantly to airport traffic. And by using the rail for the initial and final segments of the journey, the hybrid could make better use of urban space and existing railway infrastructure, and it could deliver passengers far closer to where they want to go than aircraft are able to. Thanks for watching, everyone. I'll see you next time. Thank you to our channel members.